Even though I feel this one is probably very easy and I could probably do the connect the dots method, I'm going to use the want minus have over 2 method, the math way. So remember, it's want minus have over 2. And that gives us the number of bonds that will be in this molecule. So let's get our wants. Hydrogen wants 2. And there's 2 of them. So I got that. Plus oxygen, who wants 8. So 12 electrons total are wanted by this molecule. Let's look and see what they have. Hydrogen has 1, but there's 2 of them, and oxygen has 6. So that's a total of 8 electrons. If we apply the math, 12 minus 8 over 2, that's going to give us 2 bonds. So my molecule will have 2 bonds. The first thing I do is write my oxygen, and I connect my oxygen to the outer elements using the bonds. I have 2 bonds that I need to use, and I've just used 2. If this number had been a 3 or a 4, I would start adding more bonds. I cannot add any more elements. Now I need to look at my structure and figure out, is it done? Does everyone have an octet except hydrogen, who wants 2? So let's do some counting. Remember, there are 2 electrons in each bond, and both the hydrogen and the oxygen get to count both of those. So hydrogen wants 2, it has 2 in this bond, hydrogen's done. Let's look at this hydrogen. Hydrogen has the 2 in the bond, so it's done. Oxygen has 1, 2, 3, 4 from the bonds. It wants 8, so I need to add 2 electrons to my oxygen. So let's count. We've got 2 here, 2 up here, 2 in the bond to the right, and finally 2 on the bottom. Oxygen has 8. So the Lewis structure, because I don't want all that nonsense on there, looks like this. You could have the hydrogens at 90 degrees to each other. You just want to make sure you stay on the grid where the central atom is here and everything else is 90 degrees from each other. CCl4. When I do want minus have over 2, my wants wind up being 40 electrons. My haves, let's see, I've got 4 plus 7 times 4, so I've got 32. So 40 minus 32 over 2 is 4 bonds. This is another one you probably could have done connect the dots with, but let's get some practice. Carbon goes in the center. Each chlorine comes out from it. I needed to use 4 bonds. I used 4 bonds. Now let's give everybody an octet. I only give 6 electrons to each chlorine because 2 electrons are found in the bonds. Each chlorine has a total of 8 electrons because it has 6 dots and 2 in the bond. Carbon has 2 in each bond. So 2, 4, 6, 8. It has 8. I am done. Obviously you wouldn't want all the electronics. This stuff should not be on the final drawing. But other than that, this is the final drawing. Oxygen. Oxygen probably could do connect the dots, but let's do the wants. We want 16. We have 12. That's sad. So we do 16 minus 12 over 2. We have 2 bonds. Well, that's interesting. So if I do this, I pretend one of the oxygens is the central, and I make one line, that's only 1 bond. I have to make another bond. 2 bonds must be showing. Now I give the octet. Notice I'm only giving each oxygen 4, both oxygens get to count the electrons in the bonds. So there's a total of 4 electrons in those lines, 2 for each line. And each oxygen has 2 here and 2 here. So there's 8 electrons around each oxygen. You could have the dots at 90 degrees to each other, whatever you want to do. But when you make these, rather than go around the element like you would when you were making the individual atoms, keep them together in pairs. Very important. Nitrogen. So we want 16. We don't have that. We only have 10 electrons. So 16 minus 10 over 2 is 3. That means 1, 2, 3. And you have to remind yourself that 3 lines means there are 6 electrons. So each nitrogen only needs 2 more electrons to get their 8. Remember the wants, everyone wants 8 except hydrogen who wants 2. Halves, that's your valence. So you'll look at the periodic table. Be very careful and don't confuse it with the atomic number. So now SO2, want. Well, we want 8 plus 8 times 2, so 24. We only have 18 electrons showing because each one is 6. So 24 minus 18 over 2, that means we're going to make 3 bonds. Do not add elements, just make more bonds. So sulfur and oxygen, I've used 2 bonds. Now I've used 3. I need to give everyone an octet. That includes the center. So I'm putting 4 total on the oxygen because remember there's 2 for each line. So this outer oxygen has its 8. Sulfur has 3 lines of 2 each. So right now it only has 6. So it needs 2 dots. I come over here to the far left oxygen. It has a line, so that's 2 electrons. So here's 4, 6, and 8. I'm done. Carbon dioxide. So we want 24. You'll see the same numbers popping up again and again. We have, let's see, 4 plus 6 times 2, 16. 24 minus 16 over 2. Let's see, that would be 4 bonds. That's a lot of bonds. Let's see. Carbon and oxygen and oxygen. I've only used 2 of the bonds. There's a couple different ways you could go with this. Remember, nature likes symmetry. And I would just give each of these an additional bond. So 4 bonds are now showing. It is technically not wrong if you give one bond on one side and a triple bond on the other. I just don't recommend it. Look for balance. So 4 bonds are showing. Carbon has 8 electrons. We just need to give the outer oxygens their 8. CO3 2- carbonate, a polyatomic ion, has a molecular structure, so let's figure out what it is. It wants, we've got a total of 32 electrons. What it has is a little different. Let's see, it has 4 for carbon, 6 times 3 for oxygen, and somebody just gave up 2 for the cause. If you add that up, you have 24. So 32 minus 24 over 2, you have 4 bonds. So let's make this happen. We have a carbon connected to 3 oxygens. Do not add an oxygen. There's only 3 in the formula. Okay, we've got 3 bonds showing. Oh, now we have 4 bonds showing. So our bonds are taken care of. Let's give everyone an octet. I can see very quickly that carbon is done. It's got 4 lines emanating from it. Each line is 2, so carbon's done. This oxygen only needs 4 because there's 4 in this double bond. So there's 4 electrons shown and 4 electrons here, so oxygen has its 8. The other 2 oxygens need 6 because their single bonds have 2 in them. So when you're ready to submit, for some reason I can't erase. It's not working. For a polyatomic ion, you need to put brackets around it and then a -2. That tells the reader that you have 2 more electrons in there than should be there according to the periodic table. H2SO4 is a little bit different, and I want to put this in here just to give you an idea. What you have is H2SO4 and 2 H's as well. If you did the want minus have over 2 for SO4, you get this. And then the 2 H's actually kind of go on these O's. And then you give an octet. Now, how are you supposed to know that? Well, you weren't until this moment. So this is sulfuric acid, and H's attach themselves to the O's, and it all just works out. Don't worry too much about this. It probably won't pop up on a test. NH4. So let's go back to our math method. Want, have, and the number of bonds. So want, remember hydrogen only wants 2. So we've got, let's see, we want 8 plus 2 times 4, so 16. What it has is a different story. Nitrogen has 5. Hydrogen has 1 times 4, and then someone took an electron, -1. So it has 8 electrons. So 16 minus 8 over 2, 4 bonds. So let's see, we've got nitrogen, hydrogen, 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 hydrogen. I used 4 H's because 4 H's were given. And I'm done. Nitrogen has an octet because each line has 2 electrons, and hydrogen has 2 because each line has 2 electrons. Do not alter the formula of a covalently bonded compound or ion. SOCl2. This is a little exciting. Want, have, and number of bonds. So everyone wants 8. So 8 plus 8 plus 8 times 2. So that's 32. Have 6 plus 6 plus 7 times 2. That's 26. So 32 minus 26 over 2. So 32 minus 26 over 2 is 3 bonds. So the first one always written is the center unless it's hydrogen. So sulfur, oxygen, Cl, Cl. All 3 bonds are used. Let's give everyone an octet. I'm going to add 6 electrons to every person's or every atom's, and then in the middle I'll add 2 more. You're probably questioning, how did oxygen, whatever, do not worry, just accept it. If the math works out, this is the structure. There's a lot of things going on that are a little too complex for Chem 1 for us to actually delve into with orbitals and electrons moving orbitals, but what we can do is draw the correct Lewis structure using the math. Now, if you're at the end of the test and you're like, oh my goodness, I need to figure out if this is the right answer, what you need to do is count. So if we look at this molecule, I have 8 electrons showing and 8 and 8. So I've got 8 plus 8 plus 8 showing. And then I've got this extra 2 right there, which is 26 electrons. Well, that's how much we have. That's how much is shown. I've got the right structure. Let me get that dotted line out of there so it doesn't get confusing. Okay. If you want to count it by hand, you can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. There are 26 electrons on the diagram or on the drawing. There are 26 electrons in the have pile. This is the correct structure. CS2. Well, if you kind of remember CO2, this might be very similar. Let's look. Our wants are 24. Our halves are 4 plus 6 times 2. So that's 16. 24 minus 16 over 2 is 4 bonds. Carbon is in the middle because it's written first and it's not hydrogen. Sulfur, sulfur. Well, I need 4 bonds. I can't add sulfurs, so I need to add bonds. Stick with the nature-like symmetry idea and you'll probably get it right. If you were to write the other way with a single bond and a triple bond, that is still technically correct. And when I look at this, 8 electrons are shown for each atom. N2O, want 24. Have, looks like 16. So this is saying our bonds are going to be 24 minus 16 over 2. So that means 4 bonds. I've got 2 ends. One of those ends is the center. The other end is not. And so I go ahead and live with the nature-like symmetry. Again, if you put a triple bond on one side or the other, it would technically be correct. It's something we're going to study on Friday. So 4 bonds are shown. I need to give everyone an octet. My central atom already has it. It has 4 lines around it, and each line is 2, so it has an octet. The oxygens, however, the oxygen and the nitrogen need 2 more to have their octet. This is the Lewis structure minus that plus sign, or the check mark.